And that is just steam and hot water. Hey everyone, I recently made this generator system with a homemade alternator powered by a homemade charcoal gasifier system to create off-grid electricity. Now I want to add one more component that can turn the whole thing into a complete, self-sufficient power and hot water system that can run off scrap wood. I'll link the videos of all the different component builds down below, but basically the generator uses charcoal to run an engine that creates electricity, but you've got to make the charcoal first. You can gasify straight wood without doing charcoal first, but it comes with its own host of problems, and I prefer the charcoal method. But they're both good, and I'll do a video on wood gasification when I can. So today I'm going to try to make a system that'll make enough charcoal to make 1 day's worth of electricity and use the waste heat to also make 1 day's worth of hot water. So you could run the whole system once a day on scrap wood and produce all of your own electricity and hot water. I've made a design that I think will work, so let's dive right in and find out. The main part of this design is a charcoal retort. To make charcoal, we basically need to cook wood in a sealed chamber so that it doesn't have access to any oxygen so that it can't burn. That way we cook off all the water, volatile gases, and tars, and we're left with charcoal, which is mostly carbon. As the water and gases are cooking off, they need to be able to escape, or the sealed chamber would build pressure and burst. So we need a system that easily lets gases out, but it's difficult for oxygen to find its way back in. When we run the system, we start by making a small fire under the sealed chamber. This will start to heat the wood on the inside of the chamber, and the first thing that'll happen is that the water in the wood will start to boil off and escape as steam. But as more and more water cooks off, the temperature of the wood will begin to rise and it'll begin to release volatile gases. These gases are flammable, and if we pipe them under the retort, they'll begin to burn and create the heat needed to sustain the reaction. This way we can let the initial starting fire burn out, and the wood gases will take over, and the whole process will become self-sustaining. Anytime you're working with fire, gases, and pressures, it can be dangerous and things can go really wrong. So make sure you know what you're doing and do it safely. I'm going to try to keep the design as simple as possible so there's almost nothing that can go wrong, because an off-grid power supply needs to be really reliable. For the prototype, I'm going to use a large ammo can. It's made of steel and it already has a fully removable and sealable lid built in. So it should be pretty easy to convert, and it's a good size for a daily batch of charcoal. The downside is that the steel is a little bit thin and it'll probably burn up faster than we ideally want. So if this prototype works out, I'll probably make a replacement out of thicker steel, but with the exact same dimensions and design. To convert it, the first thing I'll do is take off the lid. The lid has a rubber gasket built in to keep this watertight, but this would immediately burn up making charcoal. So first I'll just pop out the rubber gasket. It should be pretty clean, and then I'll just use this self-adhesive fire rope and line right around the edges to recreate the seal, but out of fire rope. So that's the lid ready to go. Next I'll add the pipe system so the gases can escape and they're directed under the retort. I'm going to use threaded pipes so that I can take them apart and clean out any tar buildup or replace individual pieces as they burn up. I'll cut a hole in the side of the container clear of the lid latch, and I'll just use a hole saw to cut this out. If you'd like some more detail on the build, we put together some project notes that you can buy for a few bucks that'll help us fund making more videos, and I'll link that down below. So now I'll take the lid back off and make a back plate for this with holes that line up. I want that to be nice and sturdy so that it creates a good seal here, but also as the steel gets hot and the weight of the pipe system is torquing down on this, I don't want this to bend or get loose. So I want to have that nice and reinforced in the back. I'll add some fire rope behind the flange to give it an airtight seal. Then I can just thread on the other pieces of pipe. I'll seal the end of the last pipe with a little cap. Now that I can get this screwed on nice and tight, I know where it'll be in the final setting, so I can mark out and drill holes that will act like a propane burner on a barbecue. So a series of holes along here, and I'll have the jets, here and here, so that the flame kind of hits the corner here and goes up over. I don't want it blasting straight into the bottom, and I don't want it shooting straight out the side. So then I can mark a row of holes down along the pipe, and I might do 1 or 2 little ones to hit the bottom, but most of the flame will be going off to the side and up here so that I don't burn out the bottom too quickly. And I'll start with smaller and fewer holes. I can always easily add more holes or make them bigger. I don't want to make them too big to start with. And one trick to mention before drilling holes like here or the holes in this flange is you want to test fit all the pipes exactly where you want them in the final product, so that when you drill the holes and then you finally tighten them, they're in the right place. If you just kind of loosely fit this in here, marked out the holes, when you go to tighten it, the holes might be on the bottom, and to get them in the right place, you have a loose connection here. So basically just test fit everything exactly where you want it, and then mark out and drill. So that is the retort itself done. Pretty simple. Now I need to make a stand that it can sit on so that the pipework stays up in the air and there's enough space below it to start the initial fire. So I'll probably have it float about that high, and I want to be able to just easily drop this in and pull it out of the stand. So I'll basically make a frame and it can rest on the 2 sides here. Pretty simple, straightforward frame. All right, that's ready to go. So now I want to build an enclosure to go around this to make sure that the heat is trapped in here, focused on converting the wood to charcoal as opposed to just escaping. And this enclosure is where I can also make the hot water. I'll make the enclosure out of 2 layers of steel that'll go all the way around it, and I can wrap a copper pipe around it to act as a heating coil to extract the heat and heat up water. There are a bunch of reasons that I'm going to go with this design, and I've previously done a bunch of tests on heating hot water with wood fires, and I'll link all those videos in the description below. I'll be pulling several ideas from all those videos, and the first one is that I don't want the copper pipe to be exposed directly to the flames. It would initially be the most efficient, you'd get the most hot water out of it, but the initial fire down below and then the syngas fire are both going to be pretty dirty flames, and you'll get a lot of creosote building up on the copper. And that is going to hurt you in a couple ways. First, it's acidic and it'll slowly eat away at the copper. And second, it will create an insulation barrier on top of the copper. So slowly over time, the copper will become less efficient at extracting the heat. And I don't want a system that I have to maintain and clean the copper coil every time. So I want to protect the copper and put it behind the first layer of steel. But that'll make the efficiency drop because I'm putting a barrier between the copper pipe and the highest temperatures. But in those other tests, I figured out a pretty good method to keep the efficiency fairly high while protecting the copper. So in between the 2 walls and around the copper pipe in the middle, I'll just fill the whole cavity with sand. It worked really well as a thermal conductor and really boosted the efficiency in the other water heating tests. But it's also really cheap and super safe to use. In the other tests, I also tried using powdered graphite, and that gave an even greater efficiency boost, but it's dirty to work with, it costs a lot more than sand, and it's potentially flammable, so if your system wasn't really sealed off from air, it could potentially ignite and begin to smolder. So sand, I think, is the better all-around material, especially for this. A lot of people commented in the other videos that liquids would work really well, like oil or water, and they'd probably be the most efficient, but there's a slew of problems with using liquid. Oils would be flammable and you're basically creating a potential bomb at that point. Definitely don't recommend that. And things like water, the system would have to be fully sealed, but it would also have to be open so that it couldn't boil and vent pressure, and you'd lose water as it evaporated as steam, so you'd have to keep topping it up. You'd get a ton of condensation on the inside walls. There's just a whole lot of different things to work out, and sand is going to be less efficient, but just so much easier. I think it's the right choice. Okay, so now I'll build the enclosure. I'll have it extend all the way to the ground so that it fully surrounds the whole thing, including the initial startup fire, except I'll leave one side open here so that I can build the fire easily. I might throw a door on or just lean a piece of steel against it to seal that up, but it probably doesn't really matter either way. And then I'll just leave a gap of 1 inch or 2 around all of the sides so that the heat can just channel up right close to the container, and then I'll have it go maybe 1 inch or 2 above the top here. Now I'll use some flat bar and cut it to fit the outside of the shape. This will be used to make a lip or a rim that'll help connect the outer shell. I'll weld it on just above the fire door. Now that the lip is welded on, I'm going to take the copper pipe and coil it around all the way to the top. Then I can just come in and cover this with the outer layer of steel and dump sand in to fill it up. I'll be using this bending spring to help get around the corners and not kink it. And I know I'll get a bunch of comments on galvanic corrosion, so I'll go ahead and address that now. Basically, galvanic corrosion is when 2 dissimilar metals are touching. One of the metals is going to lose electrons to the other metal, and the one that's losing electrons is going to corrode a lot faster. And there's a galvanic series you can look at to see which metals will react to which other ones and how. So basically, the higher a metal is, the more noble it is, and when the 2 metals are touching, the one that's more noble is protected and the one that's less noble is going to corrode faster. So in this instance, the copper is going to be touching the steel is going to be losing electrons to the copper, so the steel is going to corrode, but the copper really isn't. It might have a little bit of corrosion, but fundamentally it'll be fine. But most of it is actually going to be blocked by the sand, so there probably won't be that much contact anyway, but overall I'm just not worried about the copper. Okay, so let's get this winding. Now I'll cut the outer shell out of some thin sheet. I'll get it slightly preformed, then I'll wrap it around the coil and use a ratchet strap to tighten it down. Then I can cut some exit holes for the copper pipe. Okay, that's just about good. Because I'm still in the prototype phase, I'm just gonna use some wire to tie it down. I don't wanna weld it in place or anything so that I can't get back in if I need to modify it. So I'm just gonna hold this together with some wire and a couple of rivets. And now I'll hit all the seams with some high temp silicone just to keep all the sand inside. Okay, so this is basically done, but I can do one more thing to make it even more useful. So the heat's starting down here and it's passing up through, and it's both heating the charcoal retort and also the outside frame. But once it gets past here, I'm basically losing all of that extra energy that's left. So I'm gonna make a kind of steel basket that sits over the top so that it will kind of create a roof and contain the heat in here. So hopefully I'll boost the internal temperatures and can get more hot water out. But I can also stick tomorrow's wood in the basket and it'll be pre-drying. So by the time I load it into the retort tomorrow, it'll be a lot drier and have a lot less water to drive off in the beginning. So I'll always be one day ahead with the pre-drying. So basically I'll have pre-drying wood here, then the next day it moves into the retort to make charcoal, and the next day it goes to the gasifier. So I'm always 2 days ahead in the pre-drying, and as long as I maintain that cycle, I should always have dry wood, charcoal, and energy with hot water. Then I can just put some pieces of scrap bar across the top and just place this up on top. So now there's plenty of space to create an airflow, but it's really gonna trap heat in here, raise the temperature here, and heat this box up. Okay, to put the finishing touches on this, I'm just gonna cut this tail down. I just don't need all this excess. Then I'll attach some fittings to go from the copper to threads. Then I'll use a high temp pump and some washing machine hoses to hook up the rest of the plumbing. And it should be most efficient if I use counterflow, so I'll have the water coming in the top, circulating through, and then coming out the bottom here. All right, that's it for plumbing until I have it set up by the water tank for testing. The last thing I need to do is get the sand added in here. So this is set up and ready, and it's all plumbed in. It's going to be drawing water from the bottom here, circulating it through, and then putting it back in the top. This is a little bit insulated just to stop some of the heat losses, but in a final version, you'd want to insulate all the piping and everything to really preserve all the energy. So now I can start setting this up for the burn. First, I'll drop in the stand. Now the actual retort. Now I'll load it up with the charcoal wood. So this was just a couple dead oak branches. It's not fully dry, so it'd be better if it was fully seasoned, but it should do well enough just for a test. Then I'll just throw the lid back on. And you could just pre-do this and drop the whole thing right in. Now the scrap pieces. And again, this top system could be more refined once I'm beyond prototype stage. Then the basket. And then I expect the bottom of this to get really hot, probably hot enough that it could catch this wood on fire. So I'm just gonna put some scraps in here That will keep that wood raised up so it's not in direct contact, and I think that should be enough to prevent that from catching fire. So now I'll load up tomorrow's charcoal wood. And then I'll just use the little tiny stuff off the branches to start the initial fire down in the bottom. Please remember, likes and subscribes really help the channel grow. I love to see your comments and suggestions down below. Some of them are really helpful. And if you want to help us directly to keep the content coming, the best way to do that is to become a sponsor over on Patreon. So everything's ready to go. Fire's ready to light. There's 106 liters or 28 US gallons in this tank. The temperature of the water and the air is both 8.5 C or 47 Fahrenheit. I'll just let this go till it's finished charcoaling and we'll see how warm the water gets. And so I'll just turn the pump on and start the fire. Okay, water's flowing. Now I'll just use the plate that I cut out from there. I'll just lean it up and that should create a nice draw. So now I'll just sit back and wait and watch and take some occasional temperature measurements. All right, 10 minutes in, the fire down below is starting to really cook and the smoke has mostly cleared up, so we're getting a nice warm fire down there. The water coming out of the hose is up to 12.5 degrees, but we really haven't started any of the reaction yet. The wood inside the retort is probably still just warming up, and I doubt it's even started to really cook off the water yet. So still early days. I'll check back in another 10-20 minutes. Okay, 20 minutes in and we're really starting to pick up speed. I think we're starting to get some steam off the inside of the retort now. The water coming out of the hose is up to 23 C or 73 Fahrenheit. And it's really quite warm in here. This is definitely gonna start drying this stuff out. I did add the rest of the small stuff because that was starting to burn down. All right, the burner's kicked in, so it's now self-sustaining and providing all its own heat, and this took a little bit over half an hour to get to. Okay, it's been an hour and 10 minutes. The charcoaling process is still going on. The charcoaling wood was a bit wetter than I thought, and it's taking longer to go through and needed more startup wood. So definitely getting it fully seasoned would improve this overall. I just didn't have any fully seasoned wood and I didn't want to postpone the test. But it is working so far. But now I'm running into an issue. The tank water is 45 C now, but the water coming out of the hose is 77 degrees or 170 Fahrenheit. And that is pushing the temperature limits for this. It's fine now, but I might have to go ahead and add some cold water to the tank just to drop the temperature so it doesn't overheat by the time this is done. I think that would partially be fixed by having a faster process with fully seasoned wood, but the water heating aspect is working really well. I've been able to heat 28 gallons to 47 degrees C, and that's using just the waste heat in just over an hour. So that part of the system is working really well, and we'll just keep going and see how long it takes to finish up the charcoal. All right, it's been going for about 2 hours now, and I think it's just about done. The water heater took out so much heat that I actually had to double the water just to prevent the hoses from overheating. So there's 210 liters or 55 gallons in this. It's full to the brim, and it took that to 51 Celsius, which is about 124 Fahrenheit. And that is just steaming hot water. So the water heater system is great. It works really well. To check out the charcoal, I'm gonna have to let it fully cool down, because if I open it up and it's still hot, the charcoal would just combust and burn away and I wouldn't have any charcoal left. So I'm gonna let this sit overnight to fully cool down, and I'll be back to check out the charcoal quality tomorrow. All right, here we go to check the charcoal. And you can see most of the paint has been cooked off here. All right, that is fully charcoaled. That's great. Yeah, so that is perfect charcoal. This will be great for running the gasifier. All right, that went really well, especially the hot water. It made way more hot water than I thought it would. Like you saw, halfway through, I had to add more water to cool the system down, because it was just getting too hot for those plastic pipes. It was up to 75 C or 170 Fahrenheit, which is crazy hot. Like, you'd never need that in a domestic setting. So in the end, it went up to 210 liters or 55 gallons, the full barrel, and that got up to 51 C or 124 Fahrenheit. So it's piping hot. That could be showers, dishes, and laundry for an entire family. That is a ton of heat. And if you were making that every day, along with your electricity charcoal, it's basically all of your energy needs met. It took longer and more startup wood than I expected it to, because the wood in the charcoal retort was a lot wetter than I thought, and it took a long time to drive off enough moisture to start making the syngas to make it self-sustaining. And then the wood in the top basket dried out quite a bit. So if you had properly seasoned wood and then it was pre-dried the day before, I think it would really work flawlessly. And you could definitely set and forget this. I didn't need to do anything once it got going. I just lit the fire and walked away until it was basically done. So the whole process is basically hands off. So where this system would really shine is if you really wanted to get off fossil fuels, or if you're off-grid and so remote that propane isn't easy to handle, or if you are just really into prepping and you want a system that is really reliable power and hot water every day. This system could totally cover all your bases. One of the major benefits is that you're taking your hot water off of your energy system. So you don't need as big a battery system or solar array, because you're just removing the hot water completely from that draw. And hot water is going to be one of the largest draws on an electrical system. So you've completely separated this, and you can have a smaller electrical system or just not tap into it for the hot water, so you have a bigger backup reserve. If any of you guys try something like this, I'd love to hear about it, because the real test is how it performs over time. 3 months, 6 months, a year in, daily making your energy. My energy demands with my shop are greater than this system would provide, so I won't be fully using it like that. So I guess that's it for this one. I hope you enjoyed it. I did. It's really cool when an idea actually works, because I'm always nervous that it's not actually going to work until I test it. So having it prove out is really nice. So anyway, thanks for watching. Take care, and I'll see you again soon.